Now let's move on to the properties of intersection of sets. And you'll see a lot of similarities between union and intersection of sets. Let me show you. We have this universe and we have set A and we have set B. This time we're going to find the intersection between A and B. So A intersection B means we're going to take the region that's common between A and B. So we'll take this middle region, that's A intersection B. But if we go the other way around, we start with B and then we find its intersection with A. This time we're trying to find B intersection A. We'll still end up with this middle region. Both of them are the same, which means A intersection B is the same as B intersection A. This is also called the commutative law. If we have the universe and A, B and C as three sets and we take intersection in some order, let's say we take A and B first, let's try to find the intersection of A and B. This time we get this region and now we intersect this with the set C. We get this middle region that's common in all three of them, A, B and C, this region. That's your A intersection B intersection C. And if you change the order, let's say if you first take the intersection of B and C, we get this region and we intersect this with A. So A intersection this intersection will give us again this middle region. This will also give us the same thing. So A intersection B intersection C is the same as A intersection B intersection C. These two are the same. This is called the associative law. Let's keep going. We have A and we have phi. Let's say we try to find the intersection of A and phi. We're trying to find what's common between the set A and nothing. Well, there's nothing that's common between these two. So what we end up with is nothing. This means A intersection phi is the same as phi. This is called the law of identity element phi. Let's keep going. We have A and then we have the entire universe. What's common between these two? Well, the set A is common between these two. Everything that's inside A is also inside the universe. So if you're looking for things in common, we end up with the set A. So A intersection the universe should be equal to just A. So A intersection U is equal to A. That's called the law of U. Let's keep going. We have A and then we have A. What's the intersection of A and A? We have everything in A intersecting with everything in A. So what's common between A and A? Well, because these two sets are identical, they have everything in common. The intersection of A and A is just A. So A intersection A is equal to A. And this is called the idempotent law. Now let's finish this off with one last property, and this is my favorite because it takes care of intersection and union. Let's look at it. We have A, B and C. And we are saying that we're going to find A intersection B union C. So let's break this down. Let's first find B union C. B union C is everything that's inside the green region or the orange region. So B union C is this. And now we'll take the intersection of this with A. Let's look at what's common between this shaded region and the blue region. We have this, this and this. All three of them are common between A and this region. And this property says that there is another way to write this. I like to think about it as expanding it. So if you expand it, this is what you get. So let's see what we have. We have A intersection B. So let's find the intersection of A and B. So we have A and B and its intersection is this region, these two small regions. We'll take the union of it with A intersection C. But first let's mark A intersection B. We have this and this. Now let's see where A intersection C is. So the blue region is A and the orange region is C. If we take the intersection, we'll get this and this region. Now can you see that we have put stars on the exact same regions? Whether we start with this or we start with this, we reach the same conclusion. Both of them are the same, and that's what this property is about. This one is called the distributive law. Why distributive? Because we're distributing intersection over union. And the way to remember this one is, think of intersection as multiplication and union as addition. So A times B plus C is A times B plus A times C. That's how I remember it. And with this, we have covered most of the fundamental properties of intersection and union of sets.